Assalamualaikum and a very warm welcome to my channel. Today we are going to discuss about the errors and types of errors. Very first question is very important, that why do errors happen? Well, computers don't work with a perfect precision. They use approximations, and these approximations can lead to errors. Understanding these errors help us improve our algorithm and get better results. So let's discuss the very initial thing, that what basically errors are. So errors basically the difference between the actual value and the approximated value. So difference between actual value and approximated. The other word for approximated is calculated value. We denote the actual value with x, and approximated, or we call it a calculated value, with x static. The word error is denoted by different letters and with different names. So letters can be used as capital E, epsilon, and the words we can use error simply. So let's discuss an example. Let's suppose that our actual value is 7.893 and approximated value be 7.672. Now we want to calculate the error, so we can define as error is equals to actual value minus approximated value. So this is the formula basically. So in other words, you may write it as actual is x and the approximated is x bar. So that's how we will be able to calculate the errors. So we write it here also, the formula, that epsilon is equals to x minus x static. That is the formula for calculating the simple error. So okay, now error is equals to, our actual value is 7.893 and approximated value is 7.672. So when we subtract these values, we will get 0.221. So that's how we will calculate the simple error. Secondly, if we change our values, that is our first, and now we are going to discuss the second thing, that if the actual value is equals to 7.672 and the approximated value will be 7.893, then we will calculate the error as is equals to x minus x direct. So x should be 7.672 minus 7.893. So when we subtract it, we will get negative of 0.221. So if we consider the top one and the lower one, in the top one, the actual value is greater than the approximated value, and in the lower one, the actual value is smaller than the approximated value, due to which we get a negative error. So we conclude that error may be negative and error may be positive. Both are the possibilities. But we are not concerned about the positive and the negative sign. We are only concerned about the numerical value of the error. So that is an important thing. So error can be positive and can be negative also, but we are not concerned about the signs. We are only concerned about the values. Okay. Next we have the different types of error. The first type of error is known as the absolute error. The second one is the relative error. And the third one is percentage error. Now we are going to discuss one by one that what is absolute error, what is relative error, and what is percentage error, and how we are going to calculate it. So in that case, firstly, we are going to see that these three types, that when the actual value is known or is given, both are fine. So we are discussing these types of error initially. So first is the absolute error. So absolute value is, we are again considering an actual value as an x, and actual value, that is x, and approximated value, that should be x static. So whenever we are going to calculate the absolute error, so we can denote it as a dot e, that represents the absolute error. We wrote ea, both are the denotions, and epsilon a, all three we can use as an absolute error notations. So for that, that is mod of actual value minus approximated value. So this is similar to the simple error, but we can just take a mod. So the negative value will be shifted into a positive value. That is the only difference. So let's discuss an example. Let's suppose that if x is equals to, that is our actual value is 0.3000 into 10 raised to the power minus 1, and x static would be 0.3100 into 10 raised to the power 1. Now we are going to calculate an absolute error. So for an absolute error, epsilon a, that is equals to mod of x minus x static. So for that case, epsilon a is equals to, the actual value would be 0.3000 into 10 raised to the power 1 minus approximated value would be 0.3100 into 10 raised to the power 1. So when we subtract these value, we will get negative of 0.1. So when we take a mod, so the absolute error will be converted to 0.1. So that's how we will calculate the absolute errors. Secondly, second type of error is relative error. So if we define a relative error, so relative error is the ratio of the absolute error to the actual value. If you talk about the formula of an relative error, so that should be denoted with relative error, or you may denote it with ER, or you may denote it with epsilon R. Both are the notations of relative errors. So relative errors is basically absolute error A dot E divided by actual value, mod of actual value. So in other words, you may write it like this: x minus x static over x. So basically the actual value minus approximated value divided by your actual value. So let's discuss the example. So in that case, we are choosing x is equals to 0.3000 into 10 raised to the power 1, and x direct would be 0.3100 into 10 raised to the power 1. So now we are going to calculate the relative error. So this is the same example as we discussed for the absolute error. So we already calculated the absolute error. So we simply divide it with the actual value. So the formula would be relative error should be equals to epsilon r, sorry, not epsilon r, but A dot E. You can use any notation, any one notation. So A dot E over x mod of x. So we already calculated A dot E, so that should be equals to 0.1. So we are substituting directly over divided by mod of actual value into 10 raised to the power 1. So we can simply divide it by, and we will get 0.03333, or you may write it like this, that 0.3333 multiplied by 10 raised to the power minus 1, right? Second way is to again calculate the top numerator and then divide it by the numerator. So you can also do like this, that let's suppose the relative error should be equals to x minus x static over x. So that should be equals to your x value, that is 0.3000 into 10 raised to the power minus, 1, positive 1, minus 0.3100 into 10 raised to the power 1, and you need to divide it by the actual value, that is 0.3000 into 10 raised to the power 1. So when you divide it, you will directly get the value 0.4 times 3 and into 10 raised to the power negative 1. Right? So that's how simple pretty that you are going to find out the relative error if you know the actual value and the approximated value too. Okay, the last type of error is the percentage error. So percentage error should be defined as that relative error expresses in terms of percentage error. So how? So the percentage error should be denoted with P dot E. That should be equals to EA divided by mod of x multiplied by 100, or we simply say that the percentage error is equals to relative error multiplied by 100. So you can easily calculate the percentage error. So let's discuss an example. We are choosing the same example as we discussed in the upper two types. So in the upper, we have an x that is 0.3000 into 10 raised to the power 1, and the approximated value should be 0.3100 into 10 raised to the power 1. So for that case, either you have the solution of relative error, the result is already known, so we will directly multiply it with 100, and the second is you need to calculate it completely. So we discussed in both of these pattern. So first of all, we have known relative error, that is, we already discussed in the top, that is 0.3333 into 10 raised to the power minus 1. So for that case, percentage error should be calculated as directly multiply the relative error with 100. So we will get 0.4 times 3 negative 1 into 100. So we will get 3.333 percentage directly. Or the other thing is you need to calculate it, that percentage error should be equals to x minus x static, means actual minus approximated, over x into 100. So for that case, you need to simply do the same process again. The actual value is 0.30 into 10 raised to the power 1 minus 0.3100 into 10 raised to the power 1 and divided by 0.3000 into 10 raised to the power 1 multiplied by 100. So when you solve it, simplify it, you will directly get 3.4 3 times 3 percentage. So that's how we will calculate the percentage error. Okay, another most important concept is that if we don't have an actual value, then how we will calculate the errors, percentage error, absolute error, or relative error. So this is a very important concept because numerical methods only applied on such questions on which the exact solution is not applicable, or we are not able to find out the exact solution of the problems. So in that, most of the cases, we don't have the actual solutions. So this is a very important thing, that if we don't have actual value, then how we will able to find out the errors of the problems. So yes, so first of all, absolute error. Then the absolute error, the formula should be changed if we don't have the actual value. So we can write it as that absolute error is equals to mod current estimate minus previous estimate. Secondly, relative error. We need to close it. So in case of a relative error, we have R dot E. So that is the absolute error divided by mod of current estimate. Or in other words, we can say that current estimate minus previous estimate divided by current estimate. Similarly, we find out the value of percentage error also. So for the percentage error, we have current estimate minus previous estimate divided by current estimate. That's all for today, students, and thank you so much for tuning in. Don't forget to subscribe my channel. Take care of yourselves and Allah Hafiz.